Today I'm going to show you a little bit about how to visualize kinetic Monte Carlo results using the Chasm Viewer app. So I have here loaded a data set of an arbitrary spinel intercalation compound, and I have a couple different compositions that I ran KMC simulations for this spinel intercalation compound, as well as some different interaction parameters that represent the repulsion between the sites that the intercalant ion is laying on. That's determined here by these effective cluster interaction sliders up in the top right here. So first I'm going to show you this set of conditions where I have a low nearest neighbor interaction. And you can see in these plots in the middle the normalized chemical diffusion coefficient, correlation factor, voltage, and you can add other graphs for any other quantities that you might want to plot. This picture in the top left is to show the local environment of the current diffusion event at this time step. As we play through this movie, the picture will change with the sound, so you can hear it both audio and visually. So first, I'm going to show you that I can also display percolation quantities within this cell, which represent important types of vacancies that are required for diffusion in this system. So I can show quadruple vacancies here, shown in purple, where they're located within the kinetic Monte Carlo cell. I can show triple vacancies, and I can show double vacancies. So at this particular composition, double vacancies are most prominent within the cell, and then triple vacancies are next, and then quadruple vacancies are trailing behind that. So let's take a look at how these atoms move within this condition. I can do that by clicking this individual trajectory button or this sum trajectory button. The sum trajectory shows the trajectory of all the atoms summed together end to end. So this squiggly line here is a representation of how the atoms move as a whole. I can remove this display by clicking Clear Trajectories. And then I can look at individual atoms' trajectories as they appear in the simulation by clicking this button here. You'll hear the sound that corresponds to the atom movements as well. And you can see that as this little marker moves, showing which atom is moving, little vectors representing the trajectory of each atom is drawn behind it in a trailing manner, and the sound from the local environment is being played along with a display of what that environment looks like in this 2D analog here. So I'll go ahead and stop that by hitting Clear Trajectories. And you might have noticed that there are multiple different sounds there. And due to the degree of nearest neighbor interaction here, we don't have that much of a drop in correlation factor. It stays between 1 and 0.1 pretty consistently throughout the entire composition regime. Now if we ramp up the nearest neighbor interaction to something much higher and load a new data set, Alright, we're here in the new data set. You can see that the graphs have reloaded because this is a different set of data, and the corresponding graphs have been loaded from the file system. So I'm going to choose a directory within this kinetic Monte Carlo that corresponds to a composition that I would like. So this is roughly the same composition that I showed with the lowest nearest neighbor interaction. I'm just going to change this parameter here, so all the atoms are highlighted. And then I'm going to show the quadruple vacancies. You can see that there's roughly the same amount. I'm going to show the triple vacancies. I'm going to show the double vacancies. So this is roughly the same amount given the composition that we saw before. And if I go ahead and show the sum trajectory here, you can see that it looks like this. And then I'll clear that trajectory by clicking this Clear Trajectories button. And then I will look at the individual trajectories that are undergone in this particular KMC run. And you can see the vectors are being drawn where the atoms move, and the sounds that correspond to the environment are being played. One thing to notice is it seems to be mostly two different sounds that are occurring as we're watching this, with an occasional blip that represents a third type of environment that's being encountered due to this high nearest neighbor interaction. What's happening here is that because of this high nearest neighbor interaction, double vacancy and single vacancy hops are highly unfavorable compared to triple vacancy hops, so we're only seeing those triple vacancy hops throughout this KMC run. And another way that we can look at that is if I pause this for now, and then I take a look at the octahedral triple vacancy percolation network, and we take a look inside here, you'll find that a lot of the vectors that are being drawn are actually inside these blue circles. These blue circles represent where triple vacancies exist. So of all the vectors being drawn, most of them are within triple vacancy locations.